Alright guys, those of you who are here on Friday and in class not taking that test, you're going to want to read this or go through this lesson here, this little mini lesson. This is part 1. So a lot of you did this. You may want to skip to part 2 if you were in class on Friday, because we did a little bit of this section, intro into equations of circles, or circles and coordinates. So, and I might have a slightly different title the other day, not a big deal. We're going to talk about how to graph circles, something you've never done. You've graphed lines, you've graphed parabolas. Most of you have never graphed a circle before. So the warm-up questions we did the other day had to do with finding distance. And if those of you weren't here, you remember the way to find distance is either using Pythagorean theorem, a squared plus b squared equals c squared, or the distance formula. Now, of course, if I didn't put that up here, if I said use Pythagorean theorem here, to go, what the heck are you talking about? Because you're talking about coordinates. How would I turn that into a squared, b squared, and c squared? If you remember back to the distance formula, these formulas are the exact same thing. Where this, the difference in x's, the change in x, that's the run. That would be like a or b. The difference in y's, that's your rise. So really it's just the rise squared plus the run squared gives you the distance squared. And that's why you see the big square root thing. You take the square root at the end to get it down to a value that's, a distance on there. So each one of these, you can do this with this messy formula. I'm not a big fan of it. I like to just look at the numbers and go, hey, from 1 to 3, how far is that? Well, that's going up by 2. So I'm going to take the 2, and I'm going to square that. From 2 to 4, that's going to be the run. That's how up you're going. Sorry, stuttering on there. Well, that's also 2. So it's going to be 2 squared plus 2 squared is going to equal c squared. And again, you can do the messy distance formula if you want. I think it's kind of silly, because it's just rise squared and the run squared. And you get the square root of 8, which of course you should simplify that to 2 rad 2. I don't care about the decimal on this particular type of problem. This is a good time to pause and just try these other two. And I included the labels of the points on here so you can think of the little triangle that we're talking about here, where this is A, this is 2, we went over 2 and we went up 2, and we're really finding the hypotenuse of a triangle. C is our hypotenuse. This distance we're finding is really the distance. It's a hypotenuse. So a good time to pause and go through these two. And of course, if you look at these, it's pretty easy. The distance from here to here is 2, and the distance from here to here is 3. So you got 2 squared plus 3 squared, which of course it's 4 plus 9. That's 13. That one does not simplify. Leave it there. We don't care about the decimal today. Leave it the way it is. The other one from -2 to +2, well, that's 4 units. And from 3 down to 1, that's also 4 units. And we don't really care about the signs too much because we're squaring the numbers. You square the numbers, you're going to get 16 and 16. You get a total of 32. This, of course, you could simplify, and you probably should simplify in your paper. It's 2 times 16, which means it's 4 rad 2. So the length of QZ is 4 rad 2. And again, if we made a triangle out of this, this would be a 4, 4, and 4 rad 2 length. Of course, it's a special triangle. You know that one, of course. So you're going to need this concept of distance in about 2 minutes. Okay. So the next thing I want to kind of introduce here, we did it on Friday, is this equation. And it's at the top of your, it's example 2 or the next middle of your page. Hard to see on the screen up here. But y squared plus x squared equals 25. And in class on Friday I just said, graph it, go for it, do it. And I tried to give no instruction, because this is what students often do. They look at that and they go, well, I know y equals mx plus b, graphs a line. I don't know how to graph a circle. I don't know how to graph an equation like that. It's got squares in it. Maybe they're parabolas. Maybe it's a parabola. You've seen parabolas before. You know for a fact it's not linear. It's not going to be a line because of the squared terms. So if you try to graph this as a parabola, you might get something close to what it is. The way you can graph anything, I don't care if you don't know what it is or not, is with a table of values. And I usually ask classes, what's the easiest number you can plug in? And usually people say either 1 or 0. So just think about this. I think 0 is probably the easiest. If you plug in 0 for x, that means you don't have that term. It means y squared is equal to 25, which means, of course, y has to be 5. 5 times 5 is 25. But there are 2 answers to this. There are 2 different points that are associated with 0 for an x value. You could also think about this equation, y squared equals 25. The answer to that equation is 5, but it's also -5. A square root in an equation also has a negative value. So there are 2 different points we graph. 0, 5 is stay there and then go up 5. And then, of course, 0, -5 is stay there and go down 5. So then, I kind of had a good good long pause in class and said, think of some other numbers we can plug in here. And we got a different variety of answers on here. Somebody figured out 3 would work. And I was kind of hinting that I wanted to avoid decimals or avoid messy radicals. If you tried 1 or 2, if you plug in 1 or 2 in here, you're going to get radicals for the other value. I was trying to avoid that, just to avoid the decimals, to keep this simple. So if you plug in 3 here for x and you square that, you get 9. Solving the equation, you'd subtract 9 from both sides, and you'd get y squared is equal to 16. And all that's doing is plugging in 3 and simplifying. And of course, then you'd realize, okay, y has to be 4. But again, same situation. There's 2 answers to this thing. The square root of 16 could be 4, could also be negative 4. And there's sort of this realization period that, wow, there's a whole bunch of other values. So I've got these 2 here. Somebody in class mentioned maybe this was a parabola turned sideways. Maybe it's going to go this way. You haven't seen a parabola turned sideways before. And of course, somebody realized, wait, if you plug in negative, if these both work for positive and negative, then the 3's could also be positive and negative. Essentially, any combination of 3 and 4 would work. So I originally want to get 10 points here. That's where most of these are going to come from. Just combinations of 3 and 4. So this is left 3 and up 4. This one's left 3 and down 4. So we've got this quadrant, the negative quadrant. You've got the positive quadrant, negative positive quadrant, quadrant 2. You've got a whole bunch of points. And as we work out from this, somebody suddenly realizes, wait a minute, up here we could have actually plugged in 0 for y, and we'd have gotten 5 for x. There's another one you could have gotten. And you come up with all these values, which are, again, just combinations of either 0, 5, or 4 and 3. And eventually, if you plot all these points, you start to realize that this thing is circular. This original equation is the equation for a circle. So that's kind of where we're at right now. I asked everybody to think about this question, explain what every one of these points has in common. And somebody very well said it. They're coplanar. True. That's one part of this thing we're coming up with here. The other thing they have in common is they're all the same distance from the origin, or they're equidistant from the origin. Now, if you remember back to your definition of a circle, this is the definition of a circle. And it comes from this equation that looks a lot like a parabola. Parabola would not have the y squared. The parabola would just have only one of those values squared. So I'm going to jump into part 2. Most of you we got through some part of this on Friday. Part 2 is where I'm going to tell you what this equation represents in here. So I'm going to pause it here and go on to the second part.